Thanks for joining Leveraging Service Maps with Honeycomb. And my name is David Marchante. I am an implementation engineer at Honeycomb. I run public workshops, onboarding for new clients and customers. And yet today I'll be running this webinar about service maps. So another service map attempt. I'll be turning off my video now, and then we can focus on the presentation. Can everybody see my screen? Just want to make sure.
Yes.
Okay. All right, thank you. So there have been many attempts at service maps over the years, and with a mixed history of success. What happens oftentimes is that they're not dynamic, and once you get to a certain point within your system, it just becomes a big mess of spaghetti. So usually beyond like 40 some odd services of distributed systems, then you start getting a lot of noise, and it becomes more difficult to kind of filter out the noise within your service map, so that way it's useful to you. There are things that Honeycomb has implemented with our technology outside of service maps that do in fact make service maps more useful, and also we apply those same principles within our service map. So in our philosophy is the implementation of a core analysis loop. So we start from an unknown, we form an hypothesis, and then we iterate over those hypotheses to arrive at certain answers to questions for issues that may be in your systems. And we do that through high cardinality data. We can do it through isolating. We can also do it through filtering and querying. And within our service maps, we have allowed for this isolating of specific services and their specific dependencies. And it makes filtering possible on those services. So whatever attributes are available in that associated data set should be available to you there within your filtering and querying. Finally, the querying that allows you to ask questions of your system is available on your service map as well. All right. So, and this is kind of just the whole Honeycomb difference. We're talking about high cardinality data, isolating, filtering, and querying. So then we have service map use cases. Service maps are great for seeing the association between your systems, but there are other use cases as well. So before I go into the whole story about this, I do kind of want to show you what a service map looks like so you can have a little bit of context. So this is our systems, our demo environment, where we have a front end, and then we have distributed systems of, the current, like currency, ad service, product catalog, we have a recommendation service, and we can see how it all gets mapped out based on the different services. And we can see the services here, and the average duration for these particular things. So I just kind of wanted to give a broad overview of what it kind of looks like. So when I talk about these things, it can make sense. But we'll dive deeper into it after this slide. So use cases. There are things that Honeycomb have implemented with our technology that helps make service maps more useful, just like we said with isolating, filtering, and querying. So it also is onboarding, and when you're onboarding new engineers, is a particularly salient use case. Because as we are aware, most of us have probably gone through it, that even the most experienced engineers do need ramp up time when familiarizing themselves with new systems. So as an illustrated example, so let's say Carlos just joined as a senior engineer and they're in charge of payment service. They can then go to the service map feature to isolate the payment service. And then they can see where they are getting the most traffic from. They can see the dependent services and the services that are making calls to the payment service. So they can also query for specific things like duration to see where the slowest or fastest calls are coming from. So that's one use case, onboarding. So you can get a quick overview of what's going on with your systems with the service map. Sometimes there are issues with traces due to proper instrumentation. So let's say Carlos, he's been there for a few months. He's gotten a good grasp of the systems fairly quickly, thanks in part to service maps. And Carlos notices that one of the carts is not connecting to payments, which is an association that they would expect. After some troubleshooting, Carlos finds that there's an issue with the instrumentation that was causing the disconnect. This all started from seeing that when you're onboarding a new service, that they wasn't being connected, and then he was able to dive deeper, and then in fact that the instrumentation did need some work to get that all tied together. On that same point, when making changes to your architecture, service maps can be used to quickly identify if things are working as expected. So Carlos and his team identify that they need we need to create a new service in front of the payment service to handle traffic. So once they get those changes in, they can quickly see that the service is instrumented and making and receiving those calls as expected. So they're all tied together, and okay, we're good to go with the instrumentation, and that new service is wired up. There's also root cause analysis and debugging that you can utilize service maps for. And that is core to what Honeycomb offers and is key to understanding issues within your system. So let's say Carlos has been alerted to an issue via an SLO, or a service level objective, that has been implemented into this new payment service to monitor latency. So they navigate to the service map, they highlight those particular traces where the associated SLI, or service level indicator, which is defined by a derived column within Honeycomb, where that equals false, and basically saying that this indicator is failing. So now they can go and see and look at those all the dependent services that would be affected by that failing SLI. The highlight feature will let them identify that many systems are affected, and from here they can go to the SLO page and use the bubble up results in the SLO to drill further. And when we go through the actual demonstration, we'll kind of go through that as well. Additionally, service maps can help identify the level of adoption of changes. So let's say Carlos and their team, they've identified they want to keep track of a new attribute that they've added to their instrumentation. And now they have implemented the new payments traffic service. So Carlos can verify that this is using the filter trace operation, then typing in the field name operation. From there, they can see how many of their services have adopted this new field. So this is kind of a high-level overview of what service map use cases can give you. I'll pause here in case there's any questions at this time. You can drop them in the chat, or raise your hand. Okay, so I will keep on keeping on. All right, so I'm actually going to go to the live view of the service map. So as you see here, we have the service map, and as I discussed earlier, this is kind of an overview of what our demo service looks like. So I can hover over here, I can say front end, and I can see where all those calls from the front end are being made. If I highlight over it, I can also do that for checkout service, or I can see product catalog. So I can see we have calls coming from the front end and the checkout into the product catalog, and you can highlight it that way. I'm going to focus on the front end service. So, and clicking this here will recenter it all. So I'll go ahead and isolate the front end service. So now that I've isolated the front end service, I can see all the dependencies from the front end, or all the calls that the front end service are making. So as we see here, we can see it makes calls to the currency, to product catalog, to cart, to recommendation service, to ad service, to shipping service, to checkout service. So we can isolate. So that's one of the things we can do with our service map. So if I go back to show full service map, we can imagine a scenario where all this becomes, if we have a lot of distributed services, then this becomes very noisy. But if we can filter, if we can focus on on a particular service that we want to highlight, then in this case, I want to see front end, I want to remove the noise, I can just go ahead and click isolate, and I can isolate to everything that's associated with the front end. So, okay, I got the front end, great, cool. Some things to note here is outgoing services. So we have this listed here as well as a visual representation. We don't have any incoming services because the front end is the entry point. let's show an example of, let's say, go to product catalog. So if I go to product catalog, there's no outgoing services, but there are incoming services. So there's services making calls from checkout, recommendation, and front end into the product catalog. So you can kind of see where those different views and where the listing on the side can give you a quick overview of what's going on. So isolating the front end service, my mouse is pretty touchy, so I keep having to click this button here. So we have the front end, we've isolated the front end. We can identify the outgoing services, and we also have a list of traces here. So these are showing 5 traces from a selected time range. So it's showing 5 traces from the last 24 hours, as is listed here. You can also do the last 10 minutes. You can update this as you see fit. Okay. So some things you could do here. So let's say, all right, I want to see the services that have a high duration or have traces within them, within those requests that have a higher duration. So let's say I want to see the services that or the path that have traces that are a duration of over 1,000 milliseconds. So I'll do that. I'll say greater than 1,000. Hit enter. Okay. So I was able to say, so let's say I'm looking for latent services here, or like some requests that are more latent. So I can go ahead and say I want to display the services with only a duration of 1,000 milliseconds. So I was able to remove even more noise. So now I see, okay, the cart services, shipping service, and the checkout services, that's what's giving me some latent requests. And if I go, so here's some traces that should meet that criteria. So if I go to that trace, I should see where it meets that parameter, right? So now it's 3 seconds. So that's taking a while. So, and I can already get a quick view here. So I just isolated the services. So we have here, so I got the front end. Okay, I'm calling the cart service, and this for context is what we call the waterfall view. So this is the trace, and a trace is a set of events or spans that make up a particular request. So this is one request and the path that request takes. And each of these are a particular span within the request that has attributes and data for that event. So as we see here, I'm calling the front end service, which is the entry point. So that makes sense. Okay, so this is 3 seconds. Maybe it's slower than I expected it to be. Okay, and you can also do things like this where you can roll them up to kind of remove more noise. But that seems, so this is 2 seconds. So a lot of my latency is coming from this particular request here. Okay, so we're calling the checkout service. Okay, yeah, so that's still almost 3 seconds. So okay, so that's just noise I'm not really looking into. That's more noise, that's more noise. So within the checkout service, I could see that, okay, this is taking over 2 seconds. So that's where a lot of my latency is coming. And I could get a quick look, right? So I can see here within my trace view that I'm calling get discounts from the checkout service, and I can see there's a lot of queries here that are being repeated for a particular user actually. So just by going to that service map, looking at just latent requests and going to the trace, I was able to come down here and see, okay, I'm getting a lot of calls to a lot of queries here that are being repeated. So it gives me a starting point to kind of start that core analysis loop and start looking into different things that may be going on. One thing I want to note here as well is that, right, so I have a DB statement here, and I can update the fields. So by clicking here, I can click fields. So I can remove the database statement, right? So I can make this look however I want. But since this is a database query, I want to see what's going on there. So I'll go to database statement, and then I can see the actual statement that is being called, right? All right, so going back, so we just did that, but just by using one of the filters, by displaying the services that have a higher duration than I would typically want. Yes, there's a hand raised.
Yeah, so I noticed that you selected duration 1,000, But then on the
Yes.
edges, I see like different numbers. What's the difference between those?
Yeah, so this here is, I want to say, like the average, like you have the checkout service, which is, actually it might be actually the P95 latency. I have to double check. It might, I want to say it's the average of the requests, and you can see in the checkout it's starting to make that request much higher, to bring that average up. But I will confirm whether that is in fact true. So 80 milliseconds, right? So moving on from duration, from just filtering. Yeah, so did that answer your question? I need to confirm what exactly that metric is doing as well. I want to say it's the average.
I guess my question is, there is a number on the edge and there is a number for duration on the node, right?
Oh, you're talking
understand
about
like
here?
what's the difference? Yeah, that one and the one on the edge, like.
So this is, so on the edge is the P95 latency. And then here I want to say
for that connection
for the request, yeah.
Okay, got it.
Okay, so we've identified, okay, we got the ones with the duration of over 1,000 milliseconds. So now let's say, okay, I actually want to highlight. We did a quick look, we saw that cart service. So let's see everything that's associated with the cart server, and I can highlight that information as well. So all the requests that, make a request that have the cart service associated within that particular trace, they will be highlighted as well. So, and you can use this in different ways, right? So let's say I go back to the full map, and let's say I take out duration there. I can say duration milliseconds is greater than, and it should highlight the same information that I showed to display, and I messed it up. Okay, so all these traces have something going on with duration over 1,000 milliseconds, or that they're associated. But yeah, because the traces, they may be calling these different services. So this is highlighting the traces there, but this is just displaying the services that actually have that duration associated with it. Where to go? No service map detected. What's going on here? All right, let me go back to my duration here. All right, and then let's say I want to look at, or let me see if I can find the error code. Okay, so I see there's an error code in the shipping service and in the front end service. So I can see where my errors are happening now. So right, if I go back, where are my traces here? Highlight traces. Go back to the main service map. Go home, start from scratch. Then let me isolate this one again. There we go. Okay, I had to click on one of the services. So we'll do duration millisecond is greater than 1,000. And then we'll say, so I have traces here that should meet that criteria, as we showed. HTTP status code. Let's see if I have any errors associated with this. Oh, wrong buttons. Okay, there we go. So we see we have the shipping service and the front end service associated. So let's take a look at the trace that's associated with that. I should have an error somewhere. Okay, no error on this particular one. There should be an error somewhere, but it's not showing. So maybe it is not on the parent. So let's say I want to, so then let's say maybe my suspicion is that maybe these are child. So if I want to highlight traces with where there is a parent ID or where there's not a parent ID. So what I'm trying to say is I want the traces with that are the parent and not children. So parent ID will not exist. Does not exist. Let's see if that gives me the results that I'm looking for. Yep. Okay. So what that tells me is that the errors were on the parent trace. And now that I've isolated the parent trace, I can see here, I'm just getting the parent trace. I go to that trace and now I can see the error where I'm getting the error and I can see exactly where the error is and error true. And now I went directly to that trace. The other thing to note here is, so now that I did all this manipulation of data, you can actually see the query that is generating this view. So if I go to this query here, you can see, all right, so I'm focusing on the front end. I'm looking for durations over 1,000. So this is isolating where what I'm trying to display here. So this is taking out what I'm displaying. And then it's breaking it up by the derived column. Right. So this is kind of, you can kind of see where the query is. And let's say you have that information and you want to see what's going on. So now you can actually add some more visualization here. You wanted to look at specifically like a latency map, duration. So I can run that query and then I could start going deeper and trying to see what's going on here. So I have a high latency one here and I can just click into that trace as well and see what's going on. And then in fact, I have an error there based off, what was going on. So are there any questions about service maps at this time?
What's the trace ID derived column?
So that's
on the query.
Yeah. Where is my query? Yeah, so this is a derived column that we're creating here. So that way we can group by a trace ID. So
okay,
it's just a derived column pulling out the trace ID.
Nice.
So and we're generating that for you when you're coming from the service map to here. And that's actually what's populating this as well.
Can you show us the definition of the derived column again, please? The trace ID derived column.
Yeah, I can't. So I actually try to look for it myself. I'm gonna have to get back and I have to look into it a little bit deeper because I'm not sure what our definition itself. It's not in our data set, and it might be something that we're doing on our back end just for specifically for a service map.
I see. I was assuming it is probably associated with one of the data sets, right? Like in configure ASIC, right? Yeah.
I assumed that, right? When I was getting this presentation set up, and it's not. So it makes me think that we're creating this for in the background for the service map, just like we do in when you go to the home and you're seeing these errors. Oh, if I gotta go to the front end. So if we go to home, and like when you go to one of these data sets, like it's we're generating this for you. Well, it's not the right one, but when we go to one of these home screens, I know we create this kind of which is essentially a derived column, but we're
That
creating.
looks like a direct column. Yeah, indeed.
So, and that's
Got it.
what
Thank
I
you.
Yep.
So when you use that in the where query and it says like in and there is an ID.
Where was my where was that query?
That one. What's that ID? Where it says in result.
Yeah, that's something that we're generating for you too. Like I'm not 100% sure what this is. So in result, trace ID derived column. So in result, because we do have an in operator that you can use. So let's look. So this should only be showing the parent. Let's see. Let's look at trace IDs. Then let's look at trace span IDs. Let's remove some of these. User ID, duration, status code. Yeah, I'm not sure what that's being generated from. I was seeing if it was pulling a certain ID, but I'm not sure.
Okay, no worries.
In result. Okay. Are there any other questions regarding service maps?
I
Or
think,
anything?
yeah, I have one question, David. So I think service maps are amazing. And when you have finite number of data sets, like when data sets actually start to grow, let's say, suppose you had in the hundreds, what are your recommendations in like being able to parse it as effectively as you just showed in our demo? Like just use the isolate and like try to nail down from there, or do you have any other tricks up your sleeve for? Yeah.
So admittedly, service maps are new and we're still enhancing them. But yes, as of now, it would be, try to isolate the services that you think are of interest. And then like I said, when you want to display certain services, I would use that to kind of manipulate of what exactly you're looking for. Like if you're looking for latency or if you're looking for availability or things like that, then I would put those parameters, because all the fields that are available to you in the data set are available for you to query on here. So just like you would with a query builder, you can do the same thing with display services, and that will isolate the view of what you're trying to find. And then you can now go from there. You can either go straight to a query and build from there, or you can see, and this is to help you to see like what dependencies that you don't know may be affected, right? So that was what I would recommend. And yes, it was starting with isolate and going from there.
Yeah, that makes sense. Thank you.
Right, well, I'm still here. I'm not going to drop, but we do have a yes. There's another hand raised.
Yeah, one question. If I'm not sending 100% of the traces and we're doing sampling, how will that affect the service map that we get?
I mean, it'll affect in the way that you would query it in your data set anyway, right? So you should still have those mappings available because it's not pulling out all the data. So you should be able to see those mappings, and the ones that are of interest with the sampling will still be available for you there, and you'd have that data, right? If you're if you're using sampling and you're getting those the outliers that you want to find, whether it be errors or high latency or whatever it is, you'll still have that available to you, just like you would in your regular query.
Gotcha. Thanks.
Yep. Right. So we do have a survey. I'm still watching the chat and seeing if there's any hands up to answer any questions that come up. But we do have a survey. We value your feedback, and we do read every comment. And Bethany did put the link to the survey in the chat, and then added the secret word, and then you can get an iTest and Prod t-shirt. Yes, Cynthia.
Hi, David. I'm just curious if you know what's in the pipeline for service maps in terms of Honeycomb, like what's up and coming.
Not off the top of my head, but I'm sure we can get you a public product roadmap of what's available. We can get that sent to you.
That'd be awesome. Thank you.
All right. Okay. So we have the survey. We're still here for questions if needed. Talking about what's next. We have, introduction observability workshop. We have an advanced administration workshop as well. You can sign up for one of those. I think there's a wait list for the advanced instrumentation workshop. And thank you for joining, Alex. Yeah, so yeah, no problem. I'll still be here if anybody has questions after, and I'll just wait for everybody to drop since we did get done a little bit early. But you can have your time back if all your questions, at least for now, are answered. Yep, my pleasure.
David, I have a question for you. What other useful derived columns do you see in the examples that you're highlighting? Is there anything else that you would feel like you would recommend people try out?
Well, so when it comes to derived columns, it depends on your business and your use case, but the ones that we normally start with are like availability, which we start looking like parsing out the 500 errors, and then also latency. And the latency obviously is going to be business driven, so and service driven, depending on what makes sense for that particular service and what is normal health. And then yeah, so I'd always start with we always recommend starting with latency and availability. And then to take that next step, once you have those derived columns, and then so technically they can become an SLI, and then you can now put those and attach those to SLOs and create an SLO for availability and latency.
Got it. Yeah, I just created a success rate derived column and I tied it to an SLI and then created a burn alert on top of that. So yeah, that's kind of what I've been playing around too. Thanks.
Perfect. Yeah, you're on the right track. All right, well, thanks everybody for coming. I guess Max is the only one left. If you have any, I'm gonna wrap it up. And if you have any questions, Max, now's the time. All right, well, I thank you for joining again, and I'll give you 20 minutes back in your day.